If you listen closely to how smartphone brands talk about artificial intelligence today, you will notice something interesting. The loud promises about cloud-powered magic and futuristic assistance have started to fade into the background. In their place is a quieter, more practical shift happening inside the devices themselves. Without much fanfare, on-device AI has become one of the most important changes in modern smartphones. It does not announce itself loudly, but it is reshaping how phones perform, how they protect data, and how they feel to use every single day. On-device AI refers to artificial intelligence processing that happens directly on the smartphone rather than on remote cloud servers. Instead of sending data over the internet to be analyzed elsewhere, the phone handles many AI tasks locally using its own hardware. This change may sound technical, but it has major implications for performance, privacy, cost, and reliability. And it explains why nearly every major smartphone maker in the US is now prioritizing on-device AI as a core feature. One of the biggest reasons for the rise of on-device AI is speed. Cloud-based AI depends on network connections, server availability, and data transfer time. Even small delays can affect user experience. On-device AI operates instantly. Tasks like face recognition, photo enhancement, voice detection, and predictive text happen in real time. As smartphones are expected to respond faster and feel more seamless, relying on distant servers becomes a limitation rather than an advantage. Privacy concerns are another major driver behind this shift. US consumers are more aware than ever of how their data is collected and used. When AI tasks are handled on the device, sensitive information like voice recordings, images, and usage patterns do not need to leave the phone. This reduces exposure to data breaches and misuse. On-device AI allows companies to offer smart features while keeping personal data local, which aligns with growing consumer and regulatory pressure around data protection. Modern smartphones now include specialized components designed specifically for AI workloads. These include neural engines and AI accelerators built into mobile processors. Unlike traditional CPUs, these components are optimized for tasks like pattern recognition and machine learning inference. They perform these tasks efficiently without draining battery life. As these components became standard in flagship and mid-range devices, on-device AI became practical at scale. Battery efficiency plays a key role in this transition. Early AI features often relied on constant data transmission and heavy processing, which consumed significant power. On-device AI is far more energy efficient. By processing data locally and using specialized hardware, smartphones can deliver intelligent features without sacrificing battery life. This is critical in a market where battery performance remains one of the top consumer priorities. Photography is one of the clearest examples of on-device AI at work. Modern smartphone cameras rely heavily on AI to improve image quality. Features like scene detection, portrait effects, night mode, and image stabilization are powered by AI models running directly on the device. These enhancements happen instantly, allowing users to see results immediately. Without on-device AI, many of these features would be slower, less reliable, or impossible without an internet connection. Voice and language features are another area where on-device AI has quietly taken over. Voice typing, wake word detection, real-time translation, and speech enhancement increasingly run locally. This makes them faster and more reliable, especially in low connectivity situations. It also means users can access these features without worrying about constant data uploads. As smartphones become more central to communication, these improvements matter more than flashy demonstrations. Security is another factor driving the adoption of on-device AI. Smartphones face increasingly sophisticated threats, from malware to phishing attempts. On-device AI helps detect unusual behavior, block malicious apps, and protect sensitive data in real time. Because these systems operate continuously in the background, they can respond faster than cloud-based solutions. This strengthens device security without requiring constant user intervention. Cost considerations also influence this trend. Cloud-based AI services are expensive to operate at scale. They require ongoing server infrastructure, data storage, and maintenance. By shifting more AI processing to the device, companies reduce reliance on cloud resources. Services are expensive to operate at scale. They require ongoing server infrastructure, data storage, and maintenance. By shifting more AI processing to the device, companies reduce reliance on cloud resources, while on-device AI requires upfront investment in hardware and software. It lowers long-term operational costs. This economic reality is pushing companies to redesign AI strategies around local processing. Another reason on-device AI is rising is reliability. Cloud-based features depend on stable internet connections. On-device AI works anywhere. Whether users are traveling, underground, or in areas with poor connectivity, AI-powered features continue to function. This reliability improves user trust and satisfaction. As smartphones are expected to work seamlessly in all environments, on-device intelligence becomes essential. The rise of on-device AI is also changing how apps are designed. Developers are increasingly building applications that take advantage of local AI capabilities. This includes smarter keyboards, adaptive interfaces, health tracking, and personalized recommendations. When AI runs locally, apps can respond more quickly and feel more intuitive. Over time, this raises the baseline expectation for what smartphone apps should be able to do. Importantly, this shift is happening quietly because on-device AI is meant to be invisible. Unlike earlier tech trends that demanded user attention, on-device AI improves experiences without requiring new habits. Phones feel smarter without being more complicated. This subtlety is one reason adoption has been so widespread. Users benefit without needing to understand the underlying technology. Competition among smartphone makers is accelerating this trend. Once one major brand demonstrates the benefits of on-device AI, others must follow to remain competitive. As a result, AI hardware and features are moving quickly from premium models into mid-range and even entry-level devices. What was once a differentiator is becoming a standard expectation. Looking ahead, the quiet rise of on-device AI suggests a broader shift in how mobile technology evolves. Smartphones are becoming adaptive systems that learn from usage patterns and adjust automatically. AI enables phones to anticipate needs, optimize resources, and personalize experiences continuously. This evolution is not driven by bold marketing claims, but by practical improvements that users notice over time. The future of smartphone AI is likely to be increasingly local, efficient, and integrated. As hardware improves and software matures, more intelligence will live directly on the device. Cloud-based AI will still play a role, especially for large-scale tasks, but the balance is shifting. In the end, the rise of on-device AI in smartphones is quiet because it is practical. It solves real problems related to speed, privacy, efficiency, and reliability. It does not need to announce itself loudly to prove its value. Instead, it shows up in smoother performance, better photos, stronger security, and devices that simply work better. That quiet effectiveness is exactly why on-device AI is becoming the foundation of the modern smartphone experience.